Welcome back, guys. This is question 2.95, and the statement it has is, in a certain region of the country, it is known from past experience that the probability of selecting an adult over 80 years of age with a cancer is 0.05. Okay, so with the passage of time and what we have done previously, let me write here the given data. Okay, so given data here is given data. And for the given data and the probability of a cancer in that region for the people over 80 years is 0.05. So let me represent it with C, so that the probability of cancer is 0.05. Okay, so that is the probability of a cancer. And similarly, the probability that there is no cancer would be what? 1 minus probability of C, or 1 minus 0.05. So 1 minus 0.05 is 0.95. Okay, so if the probability of a doctor correctly diagnosing a person with cancer as having the disease is 0.78. Okay, so this is what, if a person has a disease and doctor diagnoses it correctly, that probability is 0.78. Okay, and the probability of incorrectly diagnosing a person without cancer as having the disease is 0.06. Okay, so what do we have to do here? We have to write the probability of a diagnosing it positive, such that a person has a disease, or see, that is what that is also given, and that is 0.78. Okay, and similarly, the probability that a person is diagnosed a cancer if he doesn't have it is also given, and that is 0.06. Okay, such that the person is diagnosed as positive if he doesn't have it. So that is cancer is negative while diagnosis is positive. That is what that is 0.06. Okay, so what do we have to find out? What is the probability that an adult over 40 years of age is diagnosed as having cancer? So we have to find out what. Let me write the required data here. So required data is, we want to find out what? We want to find out the probability of diagnosing any person positive. Okay, so what do we have to find out here? In order to solve it, let me write here the solution. So in order to find the solution of it, previously we have seen that in order to find the diagnosis of D plus, what do we have to find out? We have to find out the probability of D plus, given that a person has a disease, such that the probability of a disease. Okay, similarly, the probability of diagnosing positive, such that a person doesn't have a disease, okay, multiplied that the probability that a person doesn't have a disease. Okay, so that is, this is what, this is the formula which I'm going to use here, and this is also has obtained from another formula. Let me write it here. In order to find the probability of B, what do we have to find out? We have to find out the probability of B given all the possibilities it has, multiplying it with all these single probability these has, and then adding them together from I equal to n, which are the overall probabilities. Okay, so this is what, this is the formula which I am going to use here. Okay, we can also see here that these are all the values which are already given to us. Is this value is given? Yes, this is already given. So let me put it here, and that is 0.78. Okay, multiplying it with the probability of a disease or cancer, that is 0.05, adding it with the product of probability of the positive diagnosis, given that the disease is not available, that is here, that is also given here, that is 0.06, and multiplying it with the probability of C negative, and that is 0.05. Okay, multiplying them together and at the end getting the answer, what would I get here? I would get 0.096, and that is what, that is the answer of the question 2.95. Okay, so what we have seen here, that in order to find the probability of the any event B, what do we have to find out? We have to find out the probability of the event B given that another event which is connected with it, okay, such that multiplying the probability of this event as well. Okay, similarly, if this event B is dependent upon another event C, we have to multiply with it the probability of it as well, unless and until I get all the dependencies upon which this probability of B is dependent. Okay, so that is basically the solution of the question 2.95. If you have any question, you can ask me in the comment box. See you soon. Hello guys, question 2.96. Police plan to enforce speed limits by using radar traps at 4 different locations within the city limits. Okay, the radar traps at each of the locations L1, L2, L3 and L4 will be operated 40%, 30%, 20% and 30% of the time. Okay, so what is it? Let me start it from the given data. Okay, so here we can see that here we have different traps, and these traps basically work with the probability of 0.4, 0.3, 0.2 and 0.3 if a certain percent cross the limit. Okay, so therefore what is this? This is the probability that person who is over speeding, or the radar trap at location L1 traps a person when he overspeeds is basically 40% or 0.4. Okay, probability of trapping a person if he overspeeds at S2 is basically what, 0.3. Probability of trapping a person at location 3 if he overspeeds is basically 0.2. Okay, basically I am converting the percentages into the probabilities by dividing these values over 100, and similarly probability of the trap over S4 is what, that is 0.3. okay, because this is 30%. If a person who is speeding on her way to work has probabilities of 0.2, 0.1, 0.5 and 0.2 respectively of passing through these locations, okay, what is this? This is basically the probability of the overspeeding. So writing it here, let me write it here. So probability of the overspeeding at S1 of a person is 0.2, probability of it here 0 S2 is 0.1, probability at location 3 is 0.5, and this is 0.2, probability as the at the fourth location is S4, and that is 0.2. okay, so what do we have to find out here? What is the probability that she will receive a speeding ticket? Okay, what do we have to find out here? We have to find out that it is trapped. Okay, so the required one here is that person is trapped, or probability of T for a person. Okay, so this is the required one, and here in order to solve it, let me write here the solution. Okay, so in order to solve it, what we can use here, we can again use the formula which we have previously seen, and here in order to find the probability of trapping a person would be what, probability of trapping a person given that he or she will pass location Si would be here multiplying it the probability of trapping a person at location Si, then adding them together from 1 to n. Okay, and this is what, this is a formula I am going to use here. Okay, so let me use this formula here for the fourth locations, which are L1, L2, L3. So therefore probability of trapping a person would be probability of trapping a person at S1 multiplying it with the probability of S1 plus probability of trapping a person at S2 multiplying it with the probability of S2. Okay, similarly here adding with it probability of trapping at S3 multiplying it with the probability of S3, and at the end probability of T given that S4 multiplying it with the probability of S4. Okay, let me write their values here because all of those are given. Probability of T given S1 is 0.4 and probability of S1 is 0.2. So 0.4 multiplied by 0.2. Okay, similarly pt given as 2, this is here, and p as 2, this is here. So 0.3 multiplied by 0.1. Okay, similarly pt given as 3, this is here 0.2, and ph3 is 0.5. So 0.2 given 0.5, and the last one here is pt given as 4, 0.3 and 0.2, 0.3 and 0.2. Okay, so now at the end adding them all together, multiplying them, adding them, what do we get? We would get here 0.27, and there is a chance of what, 27% chance that person who is overspeeding and moving through these locations will be trapped. Okay, so this is what, this is the solution of the required quantity which we wanted to find out. Okay, so that is what, that is the solution of question 2.96. If you have any question, you can ask me in the comment box. You can see that this is what, this is basically the implementation of this formula which we have seen. So that's it for today, and I will see you soon. Welcome back guys, this is question 2.97 which we have discussed previously, that referring to exercise 2.95, what is the probability that a person diagnosed as having cancer actually has the disease. Okay, so what do we have to find out? We have to find out the probability of the actual having a disease given that he is diagnosed positive. Okay, so this is the query we have to address here. Okay, so again using the Bayes theorem, we know that probability of A given B, that is equal to the probability of B given A multiplying it with the probability of A and dividing it over the probability of B. We have proved the same equation on our previous video. So now applying it for the same problem which we have in question 2.97, we have to find out the probability of the actual disease or having the actual disease given that a person has been diagnosed as positive would be what? That would be probability of the diagnosing positive given that a person has a disease multiplying it with the probability of the disease dividing it over the probability of the diagnosis. Okay, so this is what, this is the overall scenario we have. Okay, so now looking back to the previous question, do we have all this stuff? Okay, so we can very clearly see that here we have probability of C, that is 0.05, probability of D plus given that C is positive, that is 0.78, and also we have found out here probability of D plus, that is 0.096. okay, so now let me put it here. So it would be what? So probability of D plus given C plus, how much is this? Let me see. So this is 0.78. okay, so that is 0.78 probability of C is 0.05, and dividing it over probability of D plus, what is this? This is what we have found out, and that is 0.096. Okay, let me use it here. 0.096. Okay, so now let me calculate it. Okay, how much is this? This is 39 divided by 96, which ultimately gives me the answer, that is 0.406. Okay, so this is what, this is the answer of question 2.97. Okay, so I hope you have understood the essence of such type of questions, that how to deploy them, how to use the Bayes theorem, and what are the procedure behind it. So if you have any question, you can ask me in the comment box. See you soon. Welcome guys, I hope all of you will be fine. So this is question 2.98, and the statement it has is, if the person in exercise 2.96 receive a speeding ticket on her way to work, what is the probability that she passed through the radar trap located at L2? Okay, I want to find out the probability that it is trapped at S2. Okay, given that it has received the speeding ticket on her way. Okay, so it has already been trapped. Okay, so what is the probability that after receiving the speeding ticket, the vehicle is trapped at location L2? Okay, so this is S2, and in order to find it out, I can use the Bayes theorem, and according to Bayes theorem or Bayes law, what I can find out, I can find out the probability of trapping, given that it has overspeeded at S2, and what is the probability of S2, okay, dividing it over what, probability of trapping. Okay, so these are the quantities I want to find out. So looking at the exercise 2.96, let me look at here. Okay, and here I can very easily see that all of these probabilities are given. Okay, this probability is already given 0.3, this probability of S2, this is also given, and let me see that where it is. Yes, it is also here, and that is 0.1, and this probability is also given. So let me put all these values here. Okay, so let me write all these values here. This is here probability of trapping at S2, so this is 0.3. okay, multiplying it with the probability at S2, and I have seen that this is 0.1. okay, and dividing it over what, probability of trapping, okay, that is 0.27. okay, so now finding it out, what I will have, this would be 0.03 divided by 0.27, or 3 divided by 27, or ultimately I will get here 1 by 9. Okay, so this is what, this is the solution of question 2.98, which I wanted to find out. Okay, and this is what, this is the probability of trapping at location L2 if the vehicle has received a speeding ticket. Okay, so that's it for today, in which we have seen another application of the Bayes theorem, because according to the Bayes theorem, what I have here, I will have a probability of A given B. This is always probability of B given A, multiplying it with the probability of A whole, dividing it over probability of B, which is what, which is here, and while this one is here because it is here. So that's it for today, and I will see you with some more interesting stuff in our upcoming video. See you soon. Welcome back guys, this is question 2.99, and the statement it has is, suppose that the 4 inspectors at a film factory are supposed to stamp the expiration date on each package of film at the end of the assembly line. Okay, so here we have 4 inspectors, and in the given data, let me write here the number of inspectors. So this is first, second, third, and 4th. Okay, so these are the inspectors we are going to see here. Okay, so the first inspector here is John, who stamps 20% of the packages. Okay, so the 20% of the packages are stamped by John. Okay, so let me write here the first inspector as John. Okay, and the probability of the stamping of John is how much? That is 20%, or writing it in the probabilities, it would be 0.2. Okay, so as this is a first inspector, so let me represent this stamping with S1. Okay, such that the probability of S1 is 0.2. He fails to stamp the expiration date once in every 200 packages. Okay, so he has been failed. Okay, so the probability of his failure in stamping the expiration date, given that he has stamped, is how much? That would be 1 over 200. Okay, so 1 over 200, let me calculate it. So it would be how much? It would be 0.005. Okay, so this is what, this is the probability or the conditional probability which has been given here. Okay, so similarly the second one here is Tom, who stamps 60% of packages. Okay, so the second inspector is Tom, who stamps the 60% of the packages. So therefore let me represent it with 2, such that the probability of the stamping of the second inspector is how much? That is 60%, or 0.6. And similarly with it, it is given that he fails to stamp the expiration date once in every 100 packages. Okay, so that now writing it like probability of the failure such that he stamps, okay, this would be 1 over 100. Okay, and this is 0.01. Similarly, in third one, it is Jeff. So Jeff, who stamps 15% of the packages. So the third one here is Jeff. Okay, and let me represent it with 3 such that the probability of the stamping of this third inspector is 15%. So this is 0.15. Okay, so after it, he fails to stamp the expiration date once in every 90 packages. So now here probability of the failure in stamping the expiration packages is S3. It would be 1 over 90. So calculating the 1 over 90, I will get here 0.011. Okay, so this is what we wanted to find out. And the fourth one here is Pat, okay, who stamps 5% of the packages. So Pat is the fourth inspector, and the probability of his stamping is S4, and this would be 0.05. Okay, and now it is also given that he fails to stamp the expiration date once in every 200 packages. So therefore the probability of the failure, given that this is S4, would be 1 over 200. So it would be 0.05. Okay, so this is all the given data which I have found out, and this is the essence of the questions like this one, that first of all you have to find the underlying concepts, and you have to formulate the mathematical equations or given data in the form of the mathematical variables, such that you would know that what do you want to find out and what will be the strategy which you have to follow after this one. Okay, so this is basically the overall data. After it, what do we have here? If a customer complains that her package of film does not show the expiration date, means the failure has already been occurred because no expiration date has been shown. What is the probability that it was inspected by the John? Okay, so John is the first inspector. So therefore here the required data is, what do I want to find out? I want to find out the probability that the stamping has been done by the first inspector, given that it is failed, and I want to find out this one. Okay, So this is the overall scenario of this question. So let me solve it. So in order to solve it, let me have here the solution, and we can very easily see that in order to find this condition here, what can I use here? So let me write it here. So if I want to find out this one, so in by using the Bayes theorem, what can I write here? Here I can write probability of failure given the S1, multiplying it with the probability of S1, dividing it over the probability of the failure. Okay, so this is what I want to find out, and let me call equation A. Okay, so let me have this equation A. Now in order to find it out, do I know the values of these variables? Yes, the first variable, which is probability of f given s1, this is already given. Probability of s1, this is also given, but we don't know the probability of the failure. So let me write here the probability of the failure. So in order to find it out, let me move it somehow here. Okay, so probability of the failure, and in order to find it out, I have to consider all the situations which have been happening here, and failure can also be occurred because of the inspector 1 2 3 4 who has been stamping incorrectly. So therefore I have to consider all these situations. So therefore it would be the probability of the failure such that stamping has been done by the inspector number 1, and what is the probability of the incorrect stamping or stamping of the inspector 1. Similarly, the probability of the failure given that stamping has been done by inspector number 2, but what is the probability of stamping of the inspector 2? Okay, similarly, the probability of the failure or not stamping given that stamping has been done by the inspector number 3, multiplying it with the probability of the stamping by the inspector number 3 plus the probability of the failure such that stamping has been done by the fourth inspector, and what is the probability of the stamping by the fourth inspector. Okay, so these are all the variables, so I know their values. So let me put them down, and let me use this one for their values. So for these two, let me write their values, which are here. So 0.005 multiplied by what? Here I have 2 multiplied with probability of s1, so here this s1 is 0.2. Okay, now with it, probability of f given s2, so probability of f given s2 is 0.01. With it I have to multiply by probability of s2, which is 0.6. okay, so here I will have 0.6, adding with it probability of f given s3, so this is 0.011, multiplying it with the 0.05, so 0.05. okay, similarly the last one here is probability of f given s4, so this is 0.05, and multiplying it with the probability of s4, this is also 0.05. okay, so now calculating them and then finding the solution of it, what would I get? Here I would get 0.0089. okay. So this is what we have found out, the value of probability of failure. okay, so this is the value I have found out. Now taking these values and putting them in equation number 1, so let me find this values. So probability of f given s1 is here, probability of s1 is here, so let me write these values. So 0.005 multiplied by probability of s1, this is 0.2, and dividing it over the probability of f, which is here 0.0089. okay, so now calculating it, and at the end what would I get? Here the answer of it will be 0.1124, and this is what, this is the solution of the question which I wanted to find out, and this is the solution of the statement here, that the probability of the stamping by John, if the stamping is done incorrectly. Okay. So that's it for today, in which we have seen the solution of question 2.99, and the essence of these type of questions is to first formulate the strategy by writing the required data, okay, and also the given data which is available in the statement forms, and then formulate the mathematical strategy so that we can proceed towards the solution. So that's it for today, and I will see you in our upcoming video. See you soon. Welcome back, guys. I hope all of you will be fine. So this is question 2.101, and the statement it has is: a paint store chain produces and sells latex and semi-gloss paint. Okay, so there are basically two categories of the paint it stores. So let me write them here as well. So this is given data. Okay, and given data, let me represent this X L semi-gloss. So based on long range sales, the probability that a customer will purchase latex paint is 0. So the probability that a customer will purchase latex paint is 0.75. So therefore, the probability that it will not purchase the latex paint is what, though, that will be 1 minus 0.75, or 1 minus P of L. So if he is not purchasing the latex paint, he will definitely purchase the semi-gloss, because these are the two categories in the store or in the production that a company has been producing. So therefore, it will be what? It will be the probability of purchasing is 1 minus 0.75, which is of those that purchase latex paint, 60% also purchase roll. So in this scenario, you can see that this is the condition that if he purchase something, the probability of purchasing the other thing is given. So in this scenario, he has already purchased the latex paint. So therefore, I want to find out in which he has already purchased the latex paint, and the probability that the person will also purchase a roller, which is, let me write R, which would be 60%, which is 0.6. Similarly, but only 30% of semi-gloss paint buyers purchase a roller. So therefore, now here as well, the probability of purchasing roller, given that he purchases the semi-gloss, which would be how much? That would be 30%, or 0. So the statement here is that a randomly selected buyer purchases a roller and a can of paint. What is the probability that the paint is latex? So what do I want to find out? I want to find out the probability that he buys latex, given that he has already purchased roller, and this is here have I want. So in order to do so, let me write the solution here, and in this solution the required quantity is this one. This is what? This is the what we quantity. So here, in order to find it out according to the Bayes theorem, what we know here is that the probability of the latex, given that R is purchased, is probability of R given L, multiplying it with the probability of L whole divided by the probability of the roll. So this is what we want to find. Similarly, in this scenario, the probability of R would be what? This would be the probability of a roller buying in all the scenarios. And here we have two scenarios. Either he will buy latex or semi-gloss, or, and here I want to write here that probability of purchasing roller, given that he has purchased the first category of the paint, and that is L. And what is the probability of L? This has to be multiplied with this. Similarly, the probability of the purchase of roller, given that he will purchase the second category of the paint, multiplying it with the probability of the purchase of that. So we have this thing, and let me write these values here. So I've already known these values, and this value is given already here. This is 0.6, okay, multiplied with the probability of L, which is 0.75. Similarly, probability of R given S. So probability of R given S is already given, that is 0.3, and probability of S is also given, that is 0. So this is what we have, and let me let me put 1 in A. So putting these values and the other values here as well. So these values are also here. So let me write these values here. Probability of R given L. So this is here and this is 0.6 multiplied by probability of L, and this is already given here. Well, this is 75. 0.75 and divided by the values which are given in the form of equation 1 and here. So let me write these values here. 0.6 multiplied 0.75 plus 0.3 multiplied by 0. Okay. So when I will add them and then multiply them and divide them, what will I get here? I will get here 0.8 5, and you can also prove it that the values are correct. And what this is, this question, which is what, which is basically the probability that he will purchase the latex given that he what wanted to find out. And this so that's it for today, in which we have seen another application of the Bayes theorem. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 2.103, and the statement of this question is: a truth serum has the property that 90% of the guilty suspects are properly judged, while of course 10% of the guilty suspects are improperly found innocent. Okay, so let me write here the given data. So let me write here the given data. Okay, so here, in order to do so, let me have two conditions which are P and N. PA means guilty or positive, and N means innocent. Okay, similarly here we are also using PS, in which serum guilty, okay, which is shown guilty by the serum, and similarly N of S, in which serum shows that a person is innocent. So these are the two positions which we are going to use here, and these would be the two variables. P is basically positive, which means guilty, and N is negative, which means innocent. So the efficiency of the serum has been shown here, and according to which the efficiency of it is 90%, which means that the probability of the positive in serum such that a person is already positive is 0.9 or 90%. Okay, so this is basically the efficiency it has. Okay, similarly, while contrary to this, the probability that a person is guilty while the serum shows that it is innocent is how much, that is given here, and that is 0.1. Okay, on the other hand, innocent suspects are misjudged 1% of the time, which means that the probability that a person is innocent or negative such that the serum shows that he is guilty, that is done 1% of the time, means 0.01 times. Okay, so this is what we have. If the suspect was selected from a group of suspects of which only 5% have ever committed a crime, so the probability of the actual guilties in that group is how much, that is 5% or 0.05, and from it we can also see that the probability of the actual negatives in that group would be how much? That would be 1 minus probability of the positives, and it would be 95% or 0.95. Okay. So, and the serum indicates that he is guilty. What is the probability that he is innocent? So, here, if the serum has been showing that a person is guilty, so what is the probability that he is innocent? So, I want to find out the probability that he is innocent given that serum is showing the positive signs, and this is what the required quantity is, and this is what we have to find out, and this is the required quantity. Okay. So, this is the overall scenario which we want to find out here. This is basically for P, this is N, and all the scenarios has been listed here. So, now let me solve this question. So, let me use the black color for it. So, solving it, okay, and let me write for this one the Bayes theorem. So, the probability of N given Ps would be the probability of the Ps given N. What is the probability of N? Okay, whole divided by the probability of the positives by serum. Okay, so this is what we want to find out, and let me call it equation A. Okay, now all this data is available. This is already available and it is here. P of N is already available. This is here, but we don't know the probability of Ps. So let me write it here. So the probability of the Ps would consider all the scenarios here. If the person is positive or guilty and serum has been showing it a guilty, and a person is innocent and a serum has been showing it innocent, we have to consider both of these scenarios. So let me write them here. So the probability of the P as given that a person is guilty, multiplying it with the probability of P, okay, and plus probability of the P as given that a person is innocent, and what is the probability of the percent innocency. Okay, so this is what we have here. Now let me put their values here. P of PSP is how much? This is given, this is 0.9. okay, probability of P is 0.05 plus probability of Ps given N, this is 0.01, 0.01, and multiplying it with the probability of N, this is 0.95. Okay. So now multiplying these terms and then adding them together, what would I get? I would get here the value which would be 0.0545. okay, and so this is what we have here, and this is the value of probability of Ps. okay, so now taking it and putting it here in this equation A. So putting them in equation A, what would I get here? The equation here is probability of N given Ps, okay, and putting their values here, probability that Ps given N multiplied by Pn, these are here 0.01 multiplied by 0.95 whole divided by the value which is here. So here 0.0545. okay, so now let me multiply them and divide them. So multiplying them and then dividing it here, what would I get here? I would get 0.174. okay, so this is what, this is the solution of the required quantity which we wanted to find here, and it is showing that there is a 17.4% chance that a person who is shown guilty by the serum is actually innocent. okay. So this is basically the fundamental type of question which is solved by the Bayes theorem, and according to Bayes theorem or the fundamental equation of the Bayes theorem, these type of statements has first to be converted to the fundamental mathematical forms, and then we can very easily solve them like this. Okay, so that's it for today. If you have any question, you can ask me in the comment box. See you soon.